Hello, everyone. Thank you so much for joining us this evening. Tonight, we have a tech talk on message brokers by Myles Austin. Myles, whenever you're ready, take it away.
Thanks, Ari. Um, Today I'm going to talk about message brokers. My name is Myles Austin. I'd like to thank Remake Labs for sponsoring this tech talk today. Um, so message brokers can be extremely useful for your organization or your application, but they also come with some drawbacks. So we're going to explore that today. They're really cool. They're really interesting. They're a little bit scary. Um, so when we're talking about message brokers, we're talking about one implementation of message-oriented middleware, which is software or hardware infrastructure supporting sending and receiving messages between distributed systems. So essentially, it's a way of having different pieces of a distributed system communicate with each other. I'm talking about message brokers today, but you might have also heard about something called a message queue. So what's the deal with that? These two terms are often used interchangeably, but there's a subtle difference. Brokers have a lot of similarities to queues, but also one important difference I'll get to in a minute. So here's the basic architecture of a queue. We have producer services creating messages and adding them to first in, first out channels. Then other consumer services read those messages. In a broker, we have a similar paradigm of producers and consumers, but the broker is able to actually transform the contents of that message at the same time it's being queued. You can think of a broker as a translator between two services that might not necessarily be able to communicate without it. So, where message queues remove the need for the producer to know where it is sending a message, the broker will also remove the need for the producer to know how to format that message. That format can now be language agnostic and is standardized in something we call a protocol, which I'm going to get to in a sec. So let's use a hypothetical real life example. We're planning an app. We're going to call it Slamazon. Slamazon is going to be a marketplace for memorabilia related to the pinnacle of American culture, Warner Brothers' 1996 film Space Jam. We're obviously going to be serving billions of customers every day. So we're going to distribute our system with microservices. We're going to need an auth service so people can log in, profile services for people to manage their personal info, chat between different users, a development service so we can test new features in a safe environment. We're going to have a service for listing items. We're going to have a lot more. If we don't use a message broker, then every one of those services is going to need a direct line of communication to every other service if they want to contribute to the app working as a whole. So now imagine that we're going to containerize these services. We might end up running dozens of different instances of each service in servers across the whole world. Things are going to get complicated very, very quickly. Uh, our message broker is going to step in. It's going to take care of all the communications between these different services. It's going to give them a standardized way to communicate called a protocol. And I'm going to reiterate this again, that the broker does not care what language a service is written in or even what tech stack it's using at all. It just cares that the message conforms to the protocol standards. So like we learned before, this paradigm is called the producer-consumer model. And just for this example, we're going to demonstrate the publish and subscribe implementation of that model. So producer will emit a message into one or more queues. Then services can be subscribed to one or more queues, and they'll consume only messages in the queues to which they're subscribed. The great flexibility of this approach, though, is that now we can have services work together to fulfill the needs of our application while keeping them very loosely coupled. So let's say a Slamazon user wants to buy this very realistic, real, and perfect mug of Michael Jordan's head from me. We'll need to send a message to the checkout service so that it can begin that process. But we'll also need to message the image service so that we can show the product image to the user so they know what they're buying. And this is a super simplified example, but this is really going to show how powerful this tech can be. So now we've gotten to the point in this talk where even though we've only scratched the surface of sort of the theoretics of how this works, we're going to move on to some more concrete examples. So this does not get too rote. So here are some examples of actual message broker software. This list is not exhaustive. And more importantly, these softwares don't market themselves solely as message brokers. A lot of them do other things too. For example, you could see Redis on there. You might be surprised because it's mostly known for being a low latency storage solution, but they actually have full message broker capability. Each of these softwares have their own best use case. They each have some pros and cons, but they essentially all can fulfill similar functions, just in different ways. Uh, so not all brokers are created equal. And that goes back to what I've been saying all along, which is that not all brokers support all the protocols. And each protocol, just like the brokers that implement them, they have different trade-offs. So here are three popular brokers and the different protocols that they support. You can see some of these protocols that are more supported than others. And you can see Kafka that implements its own binary protocol over TCP. Now let's compare a few of these. So AMQP is a very popular and well-supported protocol that is built around reliability. When an AMQP message is consumed, an acknowledgement is sent to the broker to confirm the message is processed. That reliability is one reason that the financial industry really likes this protocol. Uh, Another interesting feature of AMQP is the exchange or the router. AMQP messages first go to an exchange and then a queue. And queues are bound to a specific exchange based on patterns or criteria that you can configure. So this allows you to set up really complex routing logic that you can use for different producer-consumer relationships, like the publish subscribe, which we talked about earlier. There's also point-to-point. There's also request reply. One note, though, is that by default, AMQ messages also persist. So a storage solution is something you'll want to consider if you decide to implement this protocol. Now, in contrast, we have AMQP. In contrast to AMQP, we have Stomp, which is built around simplicity. Using the same principles as HTTP, Stomp is a frame-based protocol. A Stomp frame consists of a command, a set of optional headers, and an optional body. And speaking of that, with Stomp, you get to decide the standard syntax of the delivery semantics. So that means you can customize how your application finds message destinations, while the programmer takes care of the actual action that you want to take. So you just provide a simple verb like connect, send, whatever you like, and the protocol is going to handle the rest. But you should be aware, though, that this also means the reliability of message delivery is up to you as a developer. Now, in keeping with the theme of simplicity, Stomp has fewer commands you can issue to the broker. That means that if the protocol supports what you needed to do, then you're probably not going to need a very long runway to get your app up and running if you use Stomp. Another thing that you shouldn't overlook is that since it's text-based, it's human readable, meaning it's going to be much easier to debug. So all in all, I would suggest don't sleep on Stomp. It's a pretty robust solution for basic message functionality. It's not super well utilized, I think. So what I find really interesting about protocols is that these two techniques were created to solve essentially the same problem. But if you want to descend into the particulars of the tech, then there is a whole world of detail that you can and you should consider when deciding how to build out your particular system. So bouncing back to Slamazon. Now let's see what protocol would be best for our use case. So since we are going to be serving billions of users every day, the infrastructure that's needed to support that functionality is going to be very complex. It's got to be fast so that people have real-time data when they're bidding on items. And since we're going to be handling financial transactions, then reliability is going to be key. All these factors together mean AMQP is probably going to be the best option for Slamazon as we build our retail and our user empire. So now we're going to set protocol differences aside for a sec, and it's time to compare two of the most talked about brokers today, Kafka and RabbitMQ. So just at a glance, the biggest differences are the protocols they support. And I'll have a works cited slide at the end, but I just want to shout out the Ultimate Message Broker comparison here for being a really great resource. But if you want to dive in a little deeper, Kafka is a really popular broker for very big companies because it's very versatile and low latency across large systems. There's some different verbiage that you have to learn to use Kafka. So, for example, it actually calls itself a stream processing platform, and consumers subscribe to different offsets of streams of data rather than individual messages. So Kafka does not support routing. Kafka is very versatile because there are a lot of third-party open source tools in the Kafka ecosystem that you can use to configure Kafka. There's Kafka Connect, Kafka REST proxy, the schema registry, and Kafka streams, as well as others. But one thing to note, most of these tools come from Confluent, which is third party, and not Apache itself. But the flip side of that versatility is that Kafka is very complex to set up and configure. You will need the Java development kit installed on your machine. Then you can download the Kafka binaries. Then you can download and configure Apache Zookeeper. And then you're ready to start configuring Kafka and any of the third-party tools that you happen to be using. On the other hand, RabbitMQ is comparatively pretty straightforward to set up. Out of the box, it supports AMQP protocol, but it also supports others. It also has a lot of third-party plugins that you can choose from to extend the functionality, just like Kafka. Plus, you can give messages different levels of priority, whereas Kafka does not support that. Big potential drawback, though, that there is no auto scaling by default. So that is something you're going to have to code yourself. Consider also that while both of these brokers can scale the consumers and the producers independently of each other, Rabbit is meant to scale vertically, while Kafka is meant to scale horizontally. So if using RabbitMQ, there's always going to be a limit to the amount of power that you can add to a machine, whereas with Kafka, you just add more nodes to a cluster. Also, consider RabbitMQ configurations are all written in Erlang. So likely there's going to be an onboarding process there, and the messages don't necessarily persist by default. So you would have to configure that as well. So to sum up everything that we've talked about, message brokers are a really fascinating technology used to move high volumes of data through distributed systems. Their use cases are mainly for distributed systems handling extremely high volumes of data. And if you fall below a certain threshold, then they may not be worth the time and effort to implement into your tech stack. There are a lot of different options. We only just scratched the surface in this little talk. And the same is true with different protocols that brokers use. You have a lot of different options. All the options are going to have different pros and cons, and will have different best use cases. I would encourage you to dig a little deeper in this topic because, as I've been saying all along, I only just scratched the surface with this. So I wish you the best of luck while you navigate the space. Here, my works cited. And thanks again for attending. And thanks again to Remake Labs for sponsoring this Tech Talk.
Thank you, Miles, for such an informative talk on message brokers. Unfortunately, we do not have time for questions tonight. So thank you all so much for coming, and we'll see you at the next one.